Okay, let's give you guys another example, but this time we're going to look at the case where it's 1 to the power of infinity. So whenever you encounter this, try to somehow turn it into 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 a fraction. But as it turns out, with this particular example, we're going to jump from here to a product, and then from a product we will then jump to a fraction. Okay, and remember, you can always turn a product into a fraction, because if you have a times b, you can always rewrite it as a divided by the reciprocal of b. So this is really the same as this. Well, in this example, we're going to look at a case where it's 1 to the power of infinity. So let's try and evaluate the limit of this as x tends to 0 from the negative side. Okay, so here, if you plug 0 into here, this thing here will be 1, and then plug 0 into here. Remember, cotangent of x looks something like this, and then approaching it from the left hand side, from the negative hand side, is you approaching it from the left hand side. So you are heading towards negative infinity. So here we've got a case of, yeah, there is a negative here, but we can consider this as one. When it comes to L'Hopital's rule, you can consider this scenario as this scenario. So here we've got a case of 1 to the power of infinity. So what you do is, let's say we are trying to find the limit of this. Let's say the limit of this is capital L, and it is this capital L that we're seeking. We are seeking this capital L. But what we're going to do is we are going to take the natural log of both sides. So that will then give us this. So take the natural log of this, and remember, when you take the natural log of this thing can go down here. So that's this bit here, and then the natural log of this thing here. And then right at the end, we're going to do some stuff here. Right at the end, we will need to exponentiate both sides. We will need to do this. And then e whatever over here, and then these two will cancel out, leaving you with the L, with the capital L. Remember, it is the capital L that we're seeking. We are not seeking the natural log of L, we are seeking L. But right at the end, we're going to exponentiate both sides, so that will then give us this, and then these two will cancel out, giving us capital L. Remember, it is the capital L that we're seeking. So we are trying to find the limit of this. Let's just say that limit is capital L. So from here, we're going to take the natural log of both sides. That will mean, take the natural log of this. That will mean this will move down here. That's this bit here. And then the natural log is this bit here. And then this thing stays intact. So from here, take the natural log. That will then give us this. So now let's try and evaluate it. If you look at the cotangent graph looks like this. And then as you're approaching 0 from the left hand side, you're heading towards negative infinity. So this block here is heading towards negative infinity. Now as x tends to 0, as x tends to 0 from the left hand side, sine this thing here will hang on. This thing here will head towards 0, and then you plus 1, so that's approaching natural log of 1. Remember, the natural log of 1 is here, which is 0. So this thing here, hang on, this whole thing here is heading towards 0. This thing here is heading towards negative infinity. Here you've got a case of infinity times 0 in a way, even though when it comes to L'Hopital's rule, you can consider this as this. Okay, so now we've got a scenario where it's infinity times 0, which is a product, and a product you can always turn it into a fraction. So as it stands, this thing here is infinity times 0. So we need to turn this into a fraction. So at the moment you've got two blocks multiplying together. Remember, if you have a times b, that's the same as a divided by the reciprocal of the other one. So try and somehow turn this into a fraction. So here you've got one block multiplying another block. So rewrite it as this. So rewrite this whole thing here as this thing divided by the reciprocal of this, 1 over cotangent of x. Okay, so rewrite this as a fraction. So from here, that will then take you to here. So now tidy this up. That will then give you this. Remember, 1 over cotangent of x is tan x, because tan is from here to here, and then cotangent. Well, 1 over cotangent is tan. So now let me think. Now try and evaluate this now. So as x tends towards 0, this thing here is going to be, this whole thing here will head towards 0, and then tan, remember, tan is also going to be heading towards 0. So as it stands, this thing here, we've got 0 over 0. So we can apply L'Hopital's rule now. So applying L'Hopital's rule, because it's 0 over 0, we can just concentrate on differentiating the top and then differentiating the bottom. Okay, so to differentiate this, we've done this many times. Imagine this thing as the natural log of the bubble. So you would so if you differentiate it, it will be 1 over the bubble, and then you times the derivative of the bubble itself, which will be 2 cos 2x, which is this thing here. This thing here gets multiplied to the top. That's why you've got this thing here is here, the bubble here is down here, and so on. We've done this many times. You should be able to differentiate it. So differentiate it will give you this. Differentiate this, it will then give you this. Tidy this up. That will then give you this. Because you can always imagine this as one fraction, a over b, and then you times the reciprocal of this, which would be cos squared x over 1. So this thing times this thing will give you this, and then this b here will then be this here. Now try to evaluate this thing again. So as x tends to 0, this block here will be 1. This block here will be 1. So 2 times 1 times 1, that would be 2. And then as x tends to 0, this block here will be 0. So 1 plus 0 will be 1. So it is heading towards 2. Remember, right from the start, we wanted to evaluate capital L, but then we need to take the natural log of capital L. So right from the start, with natural log of it. So now we are now at natural log of capital L equals 2. So now to remember, it is the capital L that we're seeking. We are seeking capital L. So what you do is you E equally to both sides. That will then give you this, and then now these two in a way cancel each other out. So capital L equals this. So the limit is actually E squared. Okay.